Hello and welcome to Altai Hyperworks video training and support. Today SA India Bharat 2017 we are going to see online training session day 6 where we are going to see custom part analysis like knuckle, hub, brake, rotor, disc and all. But the main motive of this video is we are trying to compare the efforts required to utilize the same analysis using solid thinking inspire and conventional method, that is by pre-processing in hypermesh, solving in OptiStrat and viewing the result in hypergraph or hyperview. So basically we have a tool called inspire. So what we will do in this session, will carry out the knuckle analysis and concept design of the knuckle, which will be optimized based on your boundary conditions by using inspire, which is Altair software, and conventional method for knuckle analysis. So this will give you a brief idea for custom part, in case of losing weights and making a lighter vehicle, inspire can help you far better. So let's see. So as per day 6 agenda, this is going to be a 3D geometry editing, meshing and analysis of the knuckle, and simultaneously we'll carry out the knuckle analysis with the inspire and with the conventional OptiStrat as well. So we'll start with the inspire.
Inspire is basically a concept optimization tool, and through which you can get, if you give so load cases, boundary conditions and your design space, it will give you the what is the optimum material layout possible through that tool very quickly. So without spending much time on introduction, let me go directly to that. This is the screen. This screen is quite self-explanatory, and this is the basic functioning of Inspire. You give that whole design space, and based upon your loads and supports, it gives you optimized concept faster and smarter and lighter. So that's the tagline of Inspire. Now, how it works: given the package space and loading condition for a design problem, Inspire quickly generates the ideal shape. Using Inspire typically results in lighter design and helps eliminate structural design problems. So it's a brake pedal. You can see that how that material layout has been appearing given that design space. Same is the case. This is the aircraft bracket. Inspire is very easy to learn, and you can generate very quick concept. And the interfaces, existing CAD tool, it takes input as an output. So it's very easy to learn, and it's very faster, and it talks to many of the CAD tools, or in short, it is CAD agnostic. Basically, you can use any CAD along with Inspire. One case study before we actually proceed to the tool itself says that this is 3D design system. 3D system has made that skateboard actually, which has been 3D printed, but they get the shape using Inspire. I have a whole video on it, but this is how Inspire gives very bionic kind of shape, and you need optimized geometry. Yeah, so this is the GUI of the tool, Inspire. Almost all the icons are similar, which you have used. So let me now quickly show how you can actually use it for generating a concept. So there are two ways you can actually import a thing, or you can even create some of the design space in Inspire itself. So here what I am doing is I am creating a design space in Inspire, and I will try to optimize it on top of it. So it's very easy to create in Inspire itself, or if you are not comfortable with creating in Inspire, you can import your design space from other tool as well. So just let me quickly create that design space so that So my design space creation is almost ready. Let me do one boolean so that I can combine all those parts together. And I'm done. Only thing remaining is I have to create some holes and cutouts, which are again is very quickly you can create in Inspire. So the basic philosophy of Inspire is first concept generation, and there are a number of ways you can generate concept. So but every concept generation starting point is design space, and you have an option of creating a design space in many ways. This is one of the way I'm showing, but there are many other ways possible, including within Inspire or outside Inspire. So at the end of the day, what you need is you need to have a solid block which you are telling Inspire to remove material from. So if you are well versed about the concept of topology optimization, Inspire works on the topology optimization, and you know that in topology optimization there is only removal of material and there is no addition of material possible. So you make sure when you are using Inspire, you are giving as much design space as it is actually possible, and so that Inspire give you most optimized result and most efficient one. So if you give less design space, so you may find that your the result optimization is not up to the mark. So likewise, you can apply those loads and support very quickly. You don't need to create spiders and all those things. Everything is taken care automatically. You will not see any mesh over here. What you see is only geometry. So you have to play only on the geometry, and that's why it is very easy to use. So once you are done with that, you can probably go ahead and segregate these load cases for different load cases. So right now it is, let me rename this to X, and I can create some more load case as well. Let me create some more load case, Y and Z. And let me distribute these loads accordingly. This X load case. So once you're done, you saw that how easy it is, and you don't need to create those any points or spiders or connections. Everything has been taken care automatically. And once you are done with that, you probably go for optimization and set those different parameters which are required for optimization, which you know that you can have your objective function as your maximized stiffness, or you can give your objective function as your minimized mass as well. I am assuming that since today is the last class, so you already know the concept of optimization and what is objective function and what are the constraints you can provide. But still, to that, to summarize all those things, when you are giving an objective function of maximized stiffness, you have to give a mass target of you have to give a constraint as your mass target. And in case you want to give your minimized mass as your objective function, you have an option of choosing factor of safety as your mass target. Now you also have option of selecting different load cases as we have created multiple load cases over here. So let me first do that optimization with X load case, and let me give the name of that run as X and just fire the run. And similarly, I will probably do another optimization with all the load cases X, Y, Z, and I just want to compare how my component is coming out. Now, as till now, you probably have understood what component we are going to design here. We are optimized here. We are going to get a concept of knuckle actually, which you will see what it looks for different load cases. We have given X, Y, Z similar amount of loads. Which may not be the case. I mean, I am just showing the workflow of the tool. You may use it at any of the way you would like. So this is just so what you can say hypothetical load case I am taking for designing a knuckle, which may looks very trivial actually, I mean, which is very simple. I have just simplified it enough so that I just quickly convey that message to you, that how that Inspire works. So let me make another run. Okay. Let me run another time with the optimization, with the symmetry constant as well. And when you are done with your run, then probably you can see that how it looks when you are, okay, let me open another session over here. Go there. So when run is completed, you will probably see something like this with your optimized result. So this is the optimized result for your Y load cases. No, this is optimized result for all your XYZ load case. Then you can probably see that another result which is for X load cases. So you see how easily and how quickly you could get optimized result. And not only that, once you have finalized your geometry, there is also a tool for developing the model on top of your optimized geometry. So that is called Polynob. You can quickly use this tool to build your optimized model, so that you can use that model for analysis. So you can check how strong or how good or how bad is your optimized shape is, whether you are over optimizing it or you are reducing too much material from it. So for that kind of checking, you can quickly create this nerve surfaces and make this give this part for analysis. So let me show how you can actually join it and use it for analysis. So likewise, you can completely, when you will complete that that polynomial operation for building that model, you will see something like this. You will get a model something like this, which is very smooth and very very bionic kind of shape, which optimized so Solidthinking Inspire optimization has generated. Now the beauty of it, not only this model is you can do for analysis, you can go for analysis over here and see how it is behaving as far as your analysis force and load behavior is concerned. But also you can also go for manufacturing as well. So when you want to go for analysis, you go click on this button and you can do modal as well as linear static analysis of it. You just have to click run. I don't want to show that analysis right now because it will take a little more time. And once you are done with that, you can import it in IGS or CAD format, or you can send it for your manufacturing as well. You can generate machining G code or CNC codes, and you can mill that component as well. And this is, of course, this is also suitable for your 3D printing. So all these options are possible, and this tool is very easy to use. And since you will be making 1 or 2 components for your whole vehicle, so you can either go for 3D printing or you can go for customized milling as well. And these shapes are good enough for your kind of design, because in your case production quantity is not an important criteria. So you can get most optimized shape